Let's do a little ultrasound physics review. Here are ultrasound multiple echo artifacts. In ultrasound, an echo is a reflection that does not correspond to an actual structure, or echoes that are missing, or echoes that are in the wrong location, or echoes displaying the wrong characteristics, such as incorrect size, shape, or brightness. Ultrasound artifacts occur because an ultrasound machine makes 7 assumptions about sound waves. When any of these assumptions fail to occur, an ultrasound artifact is produced. The assumptions that an ultrasound machine makes about sound waves are: number 1, sound travels in a straight line; number 2, sound travels into the tissue, encounters a structure, and travels directly back to the transducer; number 3, sound travels at a constant speed in soft tissue, 1540 meters per second; number 4, echoes arise only from structures within the main ultrasound beam; number 5, the imaging plane is thin; number 6, the amount of time it takes an echo to return to the transducer determines the depth of a structure in the body; and lastly, number 7, sound attenuates at an even rate in the tissue. When one or more of these fails to happen, an ultrasound artifact is produced. There are 5 categories of ultrasound artifacts: ultrasound beam artifacts, multiple echo artifacts, velocity error artifacts, attenuation artifacts, and Doppler artifacts. Today we're going to discuss multiple echo artifacts, and these occur based on the premise that sound travels into the tissue, encounters a structure, and travels directly back to the transducer, and the amount of time it takes an echo to return to the transducer determines the depth of a structure in the body. In reality, scattering in the tissue from strong reflectors can cause artifactual echoes. The strong reflectors can cause sound to bounce between the reflectors, and this is how we get multiple echo artifacts in ultrasound. Types of multiple echo artifacts are reverberation, comet tail, ring down, mirror image, air artifact, and speckle. Our first type of multiple echo artifact is known as reverberation. Reverberation is caused by one or more strong reflectors, such as a biopsy needle. The sound waves bounce back and forth between the strong reflector and the transducer, or back and forth between 2 strong reflectors in the tissue. This produces multiple lines of artifact inferiorly to the strong reflector or reflectors. The ultrasound appearance of reverberation is multiple parallel long echogenic horizontal lines. They will be located posterior to the strong reflector or reflectors and are often visualized in the anterior portion of cysts. Our next 2 types of multiple echo artifact are comet tail and ring down, and these are both a type of reverberation artifact. Comet tail is caused by a strong reflector, such as a needle tip, air, calcifications, a biopsy clip, etc. The sound wave bounces between the transducer and the strong reflector, resulting in multiple lines of artifact. Ring down is also a type of reverberation artifact, and this occurs as a sound wave encounters gas bubbles. The sound wave excites the gas bubbles, causing them to vibrate. The vibrations create a continuous sound wave directed back towards the transducer. Ultrasound and comet tail have the same appearance on an ultrasound. They appear as multiple short, parallel echogenic horizontal lines that extend vertically, appearing as a vertical line. Reverberation has long lines, and comet tail and ring down has short little lines. That's how we tell the difference between them. You can't tell the difference between comet tail and ring down based on ultrasound appearance. We tell the difference between them based on what is causing the artifact. Our next type of multiple echo artifact is known as mirror image artifact, and this is an artifact caused by the sound waves bouncing off of a strong reflector. It causes an artifactual carbon copy structure to appear above, below, or to the side of the strong reflector. The second structure is a copy only and is not a real structure. This is commonly seen with breast implants. The implant shell is a strong reflector, causing the mirror image artifact to appear as a second copy of an implant shell located within the lumen of the implant on the ultrasound image. Our next type of of multiple echo artifact on ultrasound is known as air artifact. On ultrasound, air, such as found in the stomach, bowel, or introduced via an ultrasound-guided procedure, appears as white hazy areas on the ultrasound image. There can be shadowing, reverberation, comet tail, and/or ring down artifacts posterior to the air. Air can be a helpful artifact. It leaves behind a white track, which shows where a biopsy needle has been in the tissue. Air can also be a hindrance by obscuring anatomy and/or pathology. Our last type of multiple echo artifact on ultrasound is known as speckle. Speckle is the grainy or dot-like echoes on an ultrasound image. Speckle echoes do not correspond to actual tissue or structures on the ultrasound image. Speckle is what gives its tissue its textured look on an ultrasound image. Speckle is a type of noise artifact, which is extraneous echoes on an ultrasound image. This is caused by echoes, which are sound waves returning to the transducer, interacting with areas of scattering in the tissue from other ultrasound pulses of sound, resulting in false echoes being sent back to the transducer. Most modern ultrasound machines today have something called speckle reduction imaging, or SRI for short, which is an ultrasound control that can either increase or decrease the amount of speckle seen on an ultrasound image, making the ultrasound image appear smoother in texture. Interested in more videos on ultrasound artifacts? Stay tuned on Wednesdays, where I'll be releasing a series of videos on ultrasound artifacts. Don't forget to like, comment, subscribe, and stay tuned for our next videos.